How do we draw that line? Yes. Can you be more explicit?
Plug in values for x and then solve for y.
Wait, Sarah, what did you say? Say that again? No, what did you say? Come on, girl, confidence. Build up confidence of the line. Do it. You've even drawn it correctly. Tell me how you did it. It goes through 0, -3, right? That's the y-intercept. And what else do we know? What else do we know? The slope is 1. We'll get it to everybody. Okay? Now, I didn't say this before we started, but I was sort of interested in how many people would do it. But what I don't want to see is something like this. Oh, wait, it was 3. And so forth. Like plugging in a dozen points and figuring out where the line is. Let's get away from that and instead think about, hey, the slope is 1. Let's pick some other point that is not near the one we already know, and then connect the 2 points because, line. Henry.
6,
3. Sure, that'll work. 1, 2, 3, 4, 5, 6, 3, and then I'm going to connect the dots. I actually like picking towards the end of the graph. That's where you're going to get the most accurate. Is to pick the 2 ends because, yeah, you can make sure that you're not a little bit off in between. The farther away you have 2 points, the easier it is to connect them with the next one. Okay, so that one, piece of cake, no problema. What about the x minus 3 quantity squared? Henry.
Maybe. I don't know if I'm right at all. Maybe since it's a parabola, the zeros are at 3 and -3.
Okay. What happens if you plug in 3?
0.
Okay. What happens when you plug in -3?
It's -6.
And then square it.
Oh. -4. Wait, sorry. Wrong. -6 you said?
Yes.
Oh.
No, you said it.
Oh, my bad. I thought you said something else. I did 6 times 4 for some reason. I'm not sure why I did that. I meant 36.
Okay, good. Yeah. So
Sorry.
if we plugged in -3, we get positive 36. So not a 0 at -3.
Okay.
Okay. Who else has an idea?
Just plug in values.
You could always do that,
Okay.
but we want to get the shape of things so that we know what it should look like, and not just pick random points because with more complicated functions that might mean that you need, 37 points in order to get the shape right. And so we want to avoid that and figure out from the get-go what the shape looks like. Thoughts about x minus 3 quantity squared? No thoughts at all. Sarah? It's facing up? Why do you think it's facing up? Yeah, there ain't nothing in front of the squared part, so it's facing up. What if there were a 6 in front of the parabola, or in front of the squared part? It wouldn't move up and down.
Oh, it's
Sorry.
Not right or left.
like bigger, like wider, skinnier.
Taller. Taller. right? Because every number that we're going to plug in, right, every number that we're going to plug in, it's going to be multiplied by 6. So it's going to stretch things up. Negative, it stretches things backwards or something. Okay, so this, what's in front of the squared part is what gets us, whether it's facing up or down, and how skinny it is. The 3, I want us to think back, go in our way back machine in our brains. No, not too far, not to early childhood, just a few months ago.
I made it to
Do you start at
Dang it!
Do you start at 0 and just move over 3 because it's,
Which direction?
I'm gonna go with
Nah.
I'm
try.
going right place inside the parentheses for x.
Yeah. Okay, so 2 things. First of all, I am sickened physically by your shirt. Okay.
You don't like it?
He's fine. He's just a showboat. It's fine. This is what happens when you get into show business too early in life.
He's rehabilitated.
It's like that whole thing with the monkey and Germany.
That was
Yeah.
2 years ago.
Okay, so anyway,
Second chances forever.
2 ways to think about this. Actually, 3 ways to think about this. I'm going to put a third way up on the board in a second. First, Brad is absolutely correct. This is one of the things that we're going to remember today. This is a remembrance day plus a little bit at the end. Okay? The stuff that affects the x shifts things horizontally. Shifts things left and right. Because it's affecting the x. And you can sort of think about it as doing the opposite. So that's the way Brad was approaching it. Shifting right, it looks like a -3 in there. So instead, we're going to move it +3.
If it was outside the parentheses, it would be for the y value and it would go in the
Up and
direction
down.
actually.
Yeah.
So if it was like 3 parentheses for x minus 3 squared.
We're going to do an example of double shift in just a minute.
Okay. So
Hold that thought. If it's just affecting the x, okay, it's going to look sort of like we do the opposite. In this case, we're going to shift it +3. The other way to think about it actually is the reverse of what Henry was saying earlier. Instead of just saying, oh, well, I see a 3, so maybe it's plus or minus 3. What happened when we stuck in +3? We get 0, right? And if it were just y equals x squared, where does it equal 0? When x is 0, right? 0 squared is 0. So to get to this place where it's going to be 0, we have to move to the right 3. We're going to have to plug in 3 to make this thing 0. So instead of being at the origin, we're going to have to plug it in 3. Okay? So this is one of our points. The vertex happens to be at 3, 0. We'll talk about shifts in the y direction in a minute. Okay, but for this one. And then for parabolas. A couple ways. Again, this is good because you can think about it in your own way. I'm going to show you one pattern. I think when we did it in Algebra 2 last year, that this is the most popular way. Parabolas follow a very definite pattern. The first one, and it's flipped on either side, right? Because there's an axis of symmetry here. Okay, so the first step is if we move over to 1, we move over 1, we move up 1. Over 1, up 1. The next time we move over 1, from where we are, we're going to go up 3. 1, 2, 3. And of course, the same on the other side. The next time we move over 1, how much do we go up? Not 4.
5.
First we did 1, then we did 3, then we do 5. Okay? Yes, like that. Now what's really going on here, because 1, 3, and 5 might be confusing you, but when you add successive odd numbers, you get squares. 1 plus 3 is 4, 1 plus 3 plus 5 is 9, 1 plus 3 plus 5 plus 7 is 16. 1 plus 3 plus 5 plus 7 plus 9 is 25. Okay? Just keep adding the next odd number, you get a square. So what's really going on here is when we move over 1, we go up 1. When we move over 2, how much total do we go up?
3.
Total. The 3 was from where we last were. If we move from the vertex, if we move over 2, we go up 4. From the vertex, if we move over 3,
5.
we go up
8. 9.
9, right? It's 3 squared. Okay? If we move over 4 from the vertex, how far are we going to go up? 16. Okay? So we just need to think about how far away from the vertex we are, and that'll tell us how much we go up. I had a feeling that this would happen. Last year, people really clung to the 1-3-5 pattern, especially the faller boys. I don't know why. But really the easier way to think about it is from the vertex, you're going to go up in squares. From the vertex, you go up 1, vertex, you go up 4, vertex, you go up 9, and so on. Okay. If there were a number out front here, like 7, then instead of going up 1, we'd go up 7. Instead of going up 4, we go up. If this were a 7, instead of going up 4, we're multiplying though. Right? 7 times this thing. So 28. 7's a big number. 7's very stretchy for a parabola. Very stretchy. If we went over 3, we wouldn't go up 9, we'd go up 63. Okay, so this number up front tells us how skinny or upside down it is. Because upside down, there's negative. In your notes, if you're just working on the board, in your notes, write down this piece of lovely information. This is what we call the general form.
I remember this.
No, wait, this is the standard form. Sorry, this is the
There's
standard.
over there in the closet.
Yes, exactly. Okay, the little
Closet.
11-person room over there.
Remember, Laura, how we did class in the tiny room last year?
It was awesome.
I was so no, they were all neat.
Okay. Anyway, back to math.
Standard form?
What? This is the standard form. And the reason this is standard is that it gives us all the information we need. We don't have to do any more work to get the information that we need to draw the parabola. What does the A do? We were just talking about this.
Stretches.
Yeah, it talks about stretch
So is that up
or
and
direction.
Down? Up and down.
Yeah. Well, I mean, yes. Because it's multiplying the total number. It's multiplying some number to get the y. So, yeah. Okay, and what are the h and the k doing?
H is horizontal.
Okay,
Placement.
and what about placement?
The origin.
Except not origin. What did you say, Christina?
Vertex.
It's the vertex, yeah. The h tells you how far to the right you go, and the k tells you how far up you go. So the vertex is located at h, k. And this standard form, dealy bop, goes for any of those standard curvy shapes that we have, like circles and ellipses. Like for a circle, the standard form has x minus h quantity squared plus y minus k quantity squared. It's got that h and the k at the center of the circle. You'll see it in the center of an ellipse, center of a hyperbola.
Right, we did that.
Yeah. Okay. So the h and the k is always like the center thing. For parabolas, it's the vertex. There's no real center for parabola. Yeah, Brad.
So when it's inside the parentheses, it's the opposite sign. Outside is the actual
Yeah, and here's what's going on with that. It's not like something weird and magical about left and right and up and down. The fact is that it's really like this.
Inside is the
Yeah. This thing that affects the x shifts you left and right, and this thing that affects the y shifts you up and down. And if you put it next to the y, they do the same thing now. Now they're both opposites.
So you're just getting y by itself.
Yeah, and that's because that's how we like doing things,
Will you
right?
ever give us a problem like that?
Not without you solving for y in your next step.
Okay.
Yeah, you can always solve for y in your next step, and remember that you do the same thing for the y and the opposite thing for the x. But what's really going on is you're doing the opposite for both. It's just that we don't have the k next to the y like where it belongs.
Okay.
And if you see this in a book in a future math class, instead of a, they might have 4p. Just a fair warning.
Why?
Well, brief side note. You know how a circle is, or could be defined as all the points that are the same distance from some other point, right? That other point is the center, and then the circle is all the points that are the same distance from that point. Right? An ellipse is this weird thing about total distance between two other points. You take like string and wrap it around and trace it around. You can get an ellipse because an ellipse is like all the points that are total distance from some other two points. Parabola. What I was looking for. It's sad. A parabola is all the points that are the same distance from that point and that line. I know, confusing, right? But think about it. So straight up and down, where are we? Where's the point that's the same distance from the point of the line? Right? Right in the middle of them?
Yes.
Okay. Now, on the other hand, so let's just draw in parabola here. Oh, that's well done. Okay. If I take this point here, this distance is the same as this distance, if I've drawn it correctly. Okay. It's just that the point, the distance from this point to the line is always straight up and down. That's how you find the distance between a point and a line, is whatever it is straight up and down. And this distance is curvy. Or, in that direction.
Always.
Yeah, so this parabola, you pick any point on that parabola, it's the same distance from this point and this line. This line is called the directrix. Definitely don't need to remember that one. This point, anybody know what this point might be called?
The focal point.
Yes, the focus.
Because we learned that in waves and optics.
Good,
This
yes.
is how waves bounce.
Yeah, because in a parabola, is that an ellipse? In a parabola, if you shine a light through the focus, it then comes straight back out. No matter where you shoot it from. Shoot it from over here, and then it'll go straight up. If it's an ellipse, it then gets focused to some other. It gets focused to the other focus. Ellipses have two foci. So if you put it through one, it gets pointed to the other one. Anyways, that's not important. It's just that's why this is a 4p. This distance here is 2p, and of course this distance here is another 2p. Don't ask me why they're called p. It's just because it's a pain in the butt. Yeah. Right.
I don't understand the thing about those two distances being equal, because if parabola was like 100, the vertex was like 100 away from the line,
Mm-hmm.
but then it was a really narrow parabola, then the distance would still be this.
Well, that's why this distance matters. So the closer this point is to the line, the fatter the parabola is.
What
The
it is-
farther this point is from the line, the skinnier the parabola will be. So the shape of the parabola is dependent on how close that point in the line are. Okay, anyways, this is the important thing. This tells you everything you need to know about the shiftiness of parabolas. Vertex, h comma k. The thing in front of the parentheses tells you either how skinny it is or whether it's upside down. So we can draw these. Okay? We'll have some practice drawing. No problema. However, there's a third shape we need to know. There is. There's a line, there's a parabola, and I'm not going to make you do much. I mean, we're going to graph like a log later, an exponential. So you're going to be happy about that, I'm sure. In addition to all the trig functions. Yeah, sine and cosine and tangent specifically. But when we're talking about the next couple weeks with the things that we're going to be graphing, in preparation for graphing the trig, one over something that's a line, one over a linear thing, 1 over x minus 3 in this case. This is called a line. This is called a parabola. This other one, confusingly enough, is called the inverse function. But the word inverse is used way too often. But it is called the inverse function. You can think about it as like the 1 over x function or something. Anybody remember what 1 over x looks like?
X.
Yes, that is true. But what about the graph?
Sideways parabola.
Not quite a sideways parabola. Like not this. That would be, first of all, that's not a function, so we cut off the bottom. That's square root. Yes. Sideways parabola is square root.
Oh. Does it come from like this way? It's like the top of the line.
No, because that would still be a line. That's just a line with a negative slope.
This isn't the answer to the question. What's the one where it's like there's one here and then there's one here and it's like but if you zoom out really far, it just looks like a straight line.
Oh, we talked about that at the very end of class. Today, Friday. We talked about that at the very end of class Wednesday, and we'll get to that. That is one of the places we're headed. But we're going to start with some easier stuff first. It's not erasing people.
No, I know. You cannot erase any of those boards, then here's the bottom.
Okay, so this is what 1 over x looks like. Here's our axes. And I'm not going to spend too much time on it. You have seen it before. Okay, it looks like that. As x gets huge, what happens to y? It gets smaller, or at least it gets closer to 0, right? Which makes sense. If you divide something by 1 billion, it gets small. Like if you've got a cookie and you want to share it with 7.3 billion of your closest friends here on Earth, that's a very, very small piece of cookie for everybody.
Depends how big.
Very, very tiny. Doesn't depend on that. Actually, no. No matter how big that cookie is, it's still going to be a small piece of cookie.
7.3
billion hectares or something.
If the cookie ellipses the Earth, then it will be.
Yeah. Okay, so
Forever attacked by
yeah. So this is what 1 over x looks like. Notice what 2 quadrants are blank.
Second and fourth.
Second and fourth. 2 reasons for that. Somebody give me a reason for why the second and fourth quadrants are blankety blank. Think about it. Okie dokie, Henry.
Well, is it because their the values can only be positive and negative, and it can't be both?
Yeah, I mean, we're dealing here with y equals 1 over x, right? Well, if x is positive, over here, and we flip it upside down, we're not going to get a negative y. It's not going to happen. Same thing over here. If we're dealing with negative x's, there's no way to get a positive y. So these are the only two possible quadrants. Just let me come up with a second reason why we can't have any down here. Hint. This inverse is the inverse function. Lincoln. Yeah, I mean, if we had something down here, would it pass the vertical line test? No, not so much. Okay, we can't have anything in the fourth quadrant because then it wouldn't pass the vertical line test.
Is that the same reason for why it's not the second quadrant too?
Yes. It can't be over here because then it would fail the vertical line test with stuff in the third quadrant. Okay.
Why isn't there a horizontal line test?
There is, if we talk about, this is going to be confusing, inverse functions, not the multiplicative inverse function.
I already understand.
Well, no, this is actually slightly good. Just briefly. It's going to be like 30 seconds. Right?
Sorry, guys.
Lincoln asked about the sideways parabola,
Yes.
right? Which is the square root. Square root and square are inverses of each other, right? They undo each other. As long as we're only talking about here, right? We can't have it down here because then it wouldn't pass the vertical line test. But of course, a parabola like that. The reason it doesn't have a full-blown inverse, like it only has an inverse for this much of it, is because it fails the horizontal line test. If it fails the horizontal line test, then it won't have an inverse, like a true inverse. We won't have this. We only have half of that because it fails the horizontal line test. So horizontal line test just tells us if there's an inverse. Because the vertical line test for this thing is the same as the horizontal line test for this thing, and vice versa. Okay. So enough of that.
That didn't really make sense.
Okay. Yeah, so this one specifically, if I remember correctly, was y equals 1 over x minus 3. I'm going to move my axes. I'm going to move them over. How far to the right do you think I should move it? 3. What I'm doing is I'm moving the center of the graph. How far up and down should I move it? Nothing, yeah, plus 0. Okay, so we're not going to move it up and down at all, but okay.
So we have to check that.
Yeah. Okay. You can think about these two asymptotes. Right, we've got a horizontal asymptote, we've got a vertical asymptote. You can sort of think about them as your new axes. So yeah, it's going to go like this, and that. And for these, I don't necessarily need you to find any points for me. Like for the parabola, you should have at least the vertex and a couple points on either side. Okay. And for a line, you need 2 points, so you can draw a line. For this one, make sure you move your axes, and make sure you get something that looks like this.
How do we know when it starts to bend?
Yeah, well, that's what I
what
want you to ignore for now. Okay. We could plug numbers in. Like if I plug in 5, what do I get for y when x is 5? 1 over 2, 1/2. So I know that if I move to 5, 1, 2, 3, 4, 5, it really should have been down there. So we could plug in several points to see how close or how far from the lines we need to get. For now, I'm looking for general shape. I don't need to salute. Okay. I want us to find what does the inverse function look like. This one looks like an inverse function that's moved 3 to the right. Okay, that's all we care about right now. We're so vain, we care about how it looks. Okay. Yeah. Yes. After you tell me something about this equation.
I can tell you that I don't know what's going on.
Well, tell me what shape it is.
Not right about
Boris.
this. It's complicated.
Yeah.
Very deep.
There's no center. Because there's no K.
What's the overall shape? I mean, is it a sine curve? I mean, what's the overall shape?
Parabola.
Yeah, it's a parabola, right? It's something squared. In fact, this is the equation I gave you for parabolas.
Oh wait,
right?
yeah, the center's just one of the numbers.
Yes.
Okay.
Yeah, don't, I mean, just because I was using H's and K's before, where's the vertex of this thing? Yeah. Go ahead, Brett. Wait, say that again? No. No. Where would it be 0?
Wait, no. Oh.
Right, where did it get shifted over?
-2.
Yes. Remember, it's like we're going to sort of do the opposite of the thing that's moving the x. Again, we can think about it as we want it to be 0, just like it is at the origin normally. Okay? This thing is shifted so that we need to make x equal to -2 to be at the origin, or to be at where it's the vertex. And this used to be 0, but we shifted it down 5. Vertex. You may remember we didn't spend huge amounts of time on it, but we talked about completing the square. We spent a couple weeks completing the square. We didn't graph after it for the most part. But this parabola started off life this way. It was x squared plus 4x minus 1. This was the parabola. To get it into a nice form, so that I can just read off what the vertex is, I completed the square. I'm not going to practice completing the square. For now, I just want us to get the shapes. Completing the square will come later. For now, I'm going to give you things like this. Okay, we're plotting parabolas. I'm going to give you things like that, or things that are easily factorable. So anyways, this one started off life like this. We like it in the standard form. We like it in the standard form because it tells us where the vertex is right away, without doing any extra work. Okay. So, if you haven't already, graph that one. After this, we're going to do 2 more and take a short break. I'm just looking at the clock. I was in a parent meeting this morning. What's for lunch?
Pizza. But yellow cake with fudge icing and things, something like that.
Is it somebody's birthday?
I fell asleep during the
All right, I'll check.
Oh yeah, pizza. You fall asleep at I had that same bear.
Oh yeah, that's a good one.
I think I threw it out on the park.
Cheese pizza and chicken noodle soup and pretzels.
I love pretzels.
Wow.
Those are my
Ooh, sweet and sour chicken on Monday. You're right. That's a good day.
Sweet, sour, and orange.
One is sweet and sour, the other one's orange.
What did it taste? I don't know. It tastes.
The orange was actually kind of spicy-ish. That's
That's the
probably the
general
most.
cell. The general cell
Yeah,
is salty.
Oh my
It
god.
didn't used to be. I
That's
don't know
like-
if you remember from when you were in middle school. It was not that salty.
It was good. And then
It was the
They
best thing to
changed
have
the
here.
sauce.
somebody said something to one of the ladies.
They probably took out the monosodium glutamate, and so they had to put salt in to compensate.
What's the monos?
I put MSG in all my cooking. It's awesome.
They
It's a
changed
sodium
the
product.
sauce.
It's MSG. There was a big MSG
Yeah,
scare
you
in the
go to, like,
80s and
Asian-
90s.
You go to Asian restaurants, it's like no MSG, no MSG.
Yeah, no, don't do that. Just have the MSG. It's awesome.
Yeah, I saw that.
It's a
on
sodium
that.
product. Only if you overdo it or if you already have high blood pressure. It's just like salt for us. Salt is worse for you than MSG.
But they changed the sauce.
Yeah. Well, MSG
They
makes
changed
the flavor awesome. Just I put it in boiling water for when I'm making noodles.
They
Yep.
should give us that lunch someday. They should have brought back those hot dogs.
Yeah. The problem was that people used to overeat when they went to like Chinese buffets, and so they would complain, "Oh, my stomach hurts every time I go eat Chinese." And then some stupid scientist, quote unquote, says, "Oh yeah, MSG is bad for you because Chinese food has MSG. You feel bad after you eat the Chinese food because you overeat." Ugh.
Have you ever heard of dihydrate monoxide?
Yes, I have. It's awful for you. It's everywhere. It's pervasive.
Awful.
Monoxygen hydroxide.
It's water. It's water.
They should.
What
I don't know.
city in California almost banned it? Like, law.
There was a high school kid that went around with like a petition.
He also created a website.
Yeah.
They should bring back.
Elementary school. They showed us this website so you don't believe everything you see about the tree octopus.
Oh yeah.
That's
Yeah.
what Rose did.
Oh, it was in the Pacific Northwest. Tree octopus.
Yeah, Rose did a
I learned
project on that.
the tree octopus in San Francisco.
Nice. Well, that's in the Pacific Northwest. Okay, so as Henry wrote down, as I hope you were all writing down as we were talking, it's -2, -5, so it's down there. And then, is there any coefficient in front of the parentheses? No. So it's going to be the normal one up on either side. 1, 2, 3. Another 3 up on either side. Row up on either side. I mean, connect the dots.
I have.
Oh, everyone has their phone now. Speaking of which, I need to put it in the container. Ouch. You always have to play.
Bradley.
Okay, sorry about that. So yeah, pick some numbers. In fact, if you're gonna pick only a couple points on either side, my suggestion is the bottom ones, like the ones that's 1 over 1 up, and then one that's like 3 over 1, 2, 3, and 9 up. Just because that's farther away, so you're gonna get a more accurate depiction. Whee! Whee!
Wait, doesn't it have to move over?
It did.
There's no things.
It moved over. Yeah. The vertex here is -2, -5, and the rest of it is exactly the same as every other parabola.
Okay, that's nice.
Okay? The only difference would be if there were a number here, you'd have to multiply at the end.
It would go, well,
Yeah.
So you need like up and down.
No, stretch. If this were y equals 3, x plus 2 squared minus 5, where's the vertex?
-2, -5.
Yeah, still -2, -5. Vertex didn't move. But now, when you go 1 over, how much are you going to go up?
3.
3. That's right. Right? Because this number here gets you the 1, and then you're going to multiply by 3. So 1, 2, 3. On both sides.
Nice.
If you move the x over,
It gets thinner.
it gets taller. If you want to think about it as thinner, you can. It's not exactly what's happening, but yes. It's certainly going to look thinner. I will grant you that. The next one, move 4, right? 1 over, 2 over 4 up. But instead of 2 over 4 up, we're going to go 2 over 12 up. Because we're multiplying by 3. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
So the key numbers for the basic ones, when it doesn't have like a 3 outside the parentheses, you said it was 1. You said it was 1, 3, 5.
Yeah.
1, 3,
If we're being progressive, like there's the 1. From this point, if we move 1 more over, it's 3 up. From this point, 1 over is 5 up.
And then after that, it would go to
Sure, I mean, we can go 7 up. Did you see all this? Oh. Okay. 7 up. Anyhow. What is this thing?
It's still
Think about it, and remember that I'm only asking you about 3 different kinds of functions so far.
That looked like a parabola.
I think it looks like a parabola.
That's what I
but you
thought.
could rearrange it as K.
Yeah, in fact, hold on a second. Let me switch, because I'm using H and K, right? So let's not use K, let's use Z. Yeah. Sure. So this is a parabola. Somebody tell me something about this parabola.
It'll be flipped across the x-axis.
Oh, why is that?
Because it has negative in front of it.
Yeah, in fact, you may want to write it this way. So that it looks more like the standard form.
Yeah.
Okay. Where's the vertex? Lincoln.
It is at -3, 4, or +3, -3.
3, 4. 3, 4. That's another reason why you might want to write it this way. But even this way, okay, the overall thing is going to be added 4 to it. And the thing that's affecting the x minus 3, tells you that it's being shifted to the right 3. So it's x minus 3. It doesn't matter where that x minus 3 is in the problem. Okay? If all the x's are in one place, and it's -3, it's being shifted to the right 3. So I'm going with a 3 and a 4. So vertex is a 3, 4. And what else do we know, Henry? Other than the vertex is a 3, 4?
Flipped.
Yes, that. Flipped. They call him Flipper, Flipper. Faster than lightning. No one you see is wiser than he. And you know Flipper lives in a world full of wonder.
Is that the show about the dolphin?
Hiding his plunder under the sea. I don't know what the last
That's
one
the show, and he goes.
Yes.
That used to be my favorite show. I
Yeah.
used to watch it.
That was in reruns when I was a kid.
Yeah, I used to watch the. I used to get the DVDs from the library and watch that in Gilligan's Island.
Gilligan's Island.
All right.
Gilligan's Island.
So, can I assume you can graph this one?
Yeah.
So we move on to the next one?
Yeah.
Okay. Upside down parabola.
Yeah, check.
Regular looking parabola, except that it's upside down. Center at 3, 4.
I used to get
Okay. Last one before small break.
That also. That one looks like an inverse.
Oh, that one looks like an inverse, says El Brando. Is he correct?
Probably not.
Oh, that's not nice.
Well, does it look like a line?
No.
No. Is there any sort of squared dealy bop going on?
No.
No.
It's inverse.
It's an inverse function. Now, let's think about the setup. How much is it going to be shifted?
Negative. Positive 5.
In what direction?
+5 up.
No, left.
No, I mean
Left.
left,
Right.
right.
Okay, take a break. I mean, not a real break. Take a
Let me
breath.
say +3 in the x direction and -5 or 5 in the y direction.
Wait, -5 or 5? What does that mean?
-5. I didn't mean to say that earlier.
Yeah. Okay. The thing that is affecting the x is again our good friend x minus 3. That means it's shifted to the right 3. Yeah, that's the question, isn't it? And the -5 is the thing that's affecting the whole thing. We're subtracting 5. That means we're moving down 5. So this is an inverse function. 3, -5. Yes. Okay. Oh, finishing at the same time.
We ran out of time.
Oh, yeah. Okay. Okay, thanks. Okay, it's an inverse function. And this thing that I'm writing down, you can think of as the center. You can think of it sort of like as your new origin, right? You're going to draw in asymptotes. And you're going to draw them in at 3, -5.
Wait, is that basically? Is that it?
Yes.
Okay.
It's hard to tell when you're.
Sorry.
Okay, so this is m equals 2 over x minus 3 minus 5. I'm going to draw in new asymptotes. One, 2, 3. Okay, there's 1.
And down 5.
And then horizontal line 5.
Nice.
Yeah, arrows. Okay. We're going to be that way. Whoa, whoa. Deadly.
Is this what our homework's on?
Some of it, yes.
And then the rest is straight.
Yes. There's practice. Arbitrary.
We're having a quiz on this on Monday.
Yeah.
What about the other one? Tuesday.
Well, as I told them,
They got a deal.
yeah, and we're going to be going over the homework first, anyways. Okay. Lincoln.
What's the numerator value about the graph?
Yeah. So what do we do with that too? What do we do with a drunken two? What do we do with it?
We say
Too bad.
Put them in a long boat until it's over. Put them in a long boat till it's over. Again, it's a multiplier. Okay? Any movement away from the center that we're going to have, that we normally would have had, we're now going to multiply by 2. Away from the center. So, it should basically just be skinnier. Taller, really. Because we're multiplying by 2. Multiplying by 2 makes things bigger, right? Right, exactly. So, for inverse functions only, don't worry about the numerator here. Just go ahead and draw it in.
So ignore the numerator.
And if you want to keep in the back of your head, that's going to be taller / skinnier. You can, but the result that I'm looking for is, do you know what it's shaped like? And it's going to be shaped like that,
Nice.
except not at the bottom. Holy cow.
And those we just kind of draw, right?
That's why we're ignoring the 2. Because we want to get the general shape correct, and that's the best part. Okay, so here's the issue. Sometimes, as Henry's going to find out, you don't want to put your stuff away too early.
Oh my god.
Now, the good part is, nothing is going to change from what we just did. We know 3 graphs. What are the 3 graphs?
Inverse, parabola, line.
Yeah, that's it. But we might have to get there. Now, I'm not going to ask you to do anything fancy or schmancy. I just want you to do a little division. But,
Throwback.
Why would you do this to us?
but, check it out. What's the top?
cancel.
Yeah, we're going to be able to cancel.
What do you mean?
It turns out to
Factor the top.
be it's
But
Why?
wouldn't that just make it? Oh,
x minus 3x.
that would just make it more complicated.
Well, that's C. What happens? Go ahead and divide / cancel and see.
Can you just do that?
So what
I think
what's
it's
that graph look like?
It's just a regular. Yes.
Yeah, make sure that you go all the way to the ends, by the way. And don't use arrows, just go to the end. There. Close.
Close.
Yeah, close.
What's up?
That's the question.
Oh, wait, is this?
Oh, I see.
Oh,
Well, what do you see?
I
Isn't
have
it just
an
x minus
idea.
1?
It's very close to x minus 1.
X.
X minus 1 over 1.
Yeah.
Well, that's true, but hopefully you see this. You see that we got an x minus 2, x plus 1, that's a minus 1 actually, back, over x minus 2. X minus 2's cancel, those multiplying, so we can do that. And it sure looks a heck of a lot like we could just write down that, whatever this was, x minus 2 times x plus x minus 1 over x minus 2. It sure looks like we could just graph y equals x minus 1.
Y equals x minus plus minus.
No. If we had more time, I'd have you graph this on your calculator. But wait, what?
Don't eliminate.
No, you definitely want to eliminate because this looks hard to graph, right? It's like a parabola divided by a line or something. Okay, that's hard. This looks easy to graph. Why? Because x minus 1. But we're missing something. There's a piece of information we lost when we canceled. Not a square. What piece of information did we lose when we canceled?
The -2.
What do you mean? Here's a question. What's the domain of this function?
X. That's fine.
There's only 3 things we pay attention to, right? No negatives in square roots. No zeros or negatives in logs. What's the third thing?
Those zeros on the bottom of the graph.
No divided by 0. Well, first of all, good, right? Second, when I look at this, I don't see any problem, right? There's no denominator. Right? No denominator, no problem. But there used to be a denominator up here, and at no point are we allowed to divide by 0. No problem. So what do I get here if I plug in, pulling a random number out of my hat, 2?
Oh, I get a 1.
We get
Positive.
positive 1,
Oh, whoops.
right?
Sorry,
What happens if I plug into this one?
0.
Yeah, so it's undefined. Okay? Y equals x minus 1 is just a line. This thing is a line except for what? Yeah, and what's going on at 2? How am I gonna demonstrate that it doesn't equal 2 anywhere? X squared. Yeah, there's a hole there.
Can we just do it?
Yes. 1. So we know that it's here, right? We know that it's at, if we plug in 2 here, it would be at 1. 1, 2, 1. We know that there's a hole there. Other than the fact that there's a hole there, this is just a line.
Nice.
That's what this thing looks like. It's not exactly y equals x minus 1. It's pretty close. In fact, it is the same as x minus 1 except for 1 point, an infinite number of points. This function is the same as y equals x minus 1, except at x equals 2. It's better.
So is this like a piecewise function?
You could define it as a piecewise function where it's x minus 1 from negative infinity to 2, and it's also x minus 1 from 2 to infinity.
Right.
And then at 2 it's just undefined. Yes, absolutely, we can define it that way. This is actually a way that we can do this thing. Like, oh, we need a line that's x minus 1 but has a hole. Okay, well, let's multiply the top and the bottom by x minus 2. Yay, there's a hole now. Yeah.
We're going to learn how to graph sine.
Oh, yes. We need to do these first, and that will help us graph sine equals on later. We are probably going to be let out a little early, but hang with me here. Yeah, Isabel.
Can there be multiple holes?
Yes, absolutely. For instance, if there's 2 things on the bottom and they both happen to cancel, there'd be 2 holes. I think we have one of those later. I think we only got 2 more after this. Okay, what about this one? This is a fun one. Same process. Factor and cancel. Ooh. Could we have predicted that?
Yeah.
Why?
It's the same thing.
Yeah, it's the same function, just flipped upside down.
Is this correct?
Everybody graph. Keep graphing.
Is that correct?
So close.
Oh, I need to find the full thing. But I don't know how to do that, so I guess I'm just gonna say.
Well, figure out where you're dividing by 0,
Okay.
right? And that's what you're not allowed to do.
Alrighty. Oh, okay. Actually, no.
Oh. That there is what the function looks like. It resembles 1 over x minus 1. What's the exception? What did we delete, or what did we cancel? Yeah. Right, we canceled x minus 2, right? So the information that we're missing here, I mean, it can't be 1, right? But we get that from the asymptotes. Where's the asymptotes for this one?
Over 1.
Over 1, because it's x minus which direction?
Right.
Yeah. And what about the y asymptote?
0.
Yeah, it's still at x equals 0. I mean, y equals 0. Okay, there we go. There's our asymptotes.
Pretty good.
Okay, and the information, so first of all, we can't be x equals 1, right? I mean, we got the asymptotes there. What about the x minus 2? It used to be on the bottom. So we know x can't be 2. Henry, how did you... nice. How did you get the hole? What did you do to, where you put your hole?
Because if you plug 1 in on the bottom, it'll be 0. On the new axis, I just went.
Yeah, careful.
I did it wrong. But I'm
Yeah.
technically right.
This is not new x, right? This is still just x. This is not new x minus 2 or something. It's got nothing to do with the new asymptotes. It really is just x. We know that x cannot be 2. Because that's the thing we canceled. We canceled x minus 2 equals 0. Okay, so x can't be 2. So we got a hole. And how are we going to show where the hole is? Say that again? Yeah, but how do we know where to put the circle? Yeah, just put a 2 in, right? If we need to know where it would be if it existed, just plug it in. And when we plug it in, what do we get? 1 over 1. That's a 1. So if I move over to x equals 2, y equals 1, we've got a hole there.
Yes.
And now we draw our inverse function.
Isn't it on the bottom? So
What do you mean?
is there also a hole on the
Nope. This is at x equals 2.
okay.
That is where the hole is. When x equals 2. Nothing else. And this is the only time where you should care how close you get to the asymptotes, is because we should go through the hole. And then try to make it look even on both sides. Or something. Okay, so we're looking for we have to remember what we canceled. And then we can't let what we canceled equal 0. Can't do it. Last one. This is not as complicated as it looks. Factor, cancel. Factor, cancel. Factor, cancel.
Just be confused.
Lisa, and do we know what that looks like? Yeah.
How do you do the cube?
This is what we get.
Back to the bottom. Back to the bottom.
Around 5.
You can cancel the x minus 5s,
Is that all you can do?
X plus 1.
and what are the x plus 1s? Right? Because I got x plus 1 cubed on the top,
Oh,
and x plus 1 squared on the bottom. That's good that you can cancel, because I don't know how to graph something cubed over something that's a line. I know how to graph x plus 1 quantity squared. It's a parabola.
Yeah.
Now, take a step back from this. So what is this parabola going to look like?
does not equal.
Forget the not equal for a second. What does this parabola look like?
Shifted to the left one.
Yeah.
Big body.
This is g equals x plus 1 quantity squared, which means it moves to the left one, and then just like a normal parabola.
Yes, sir. The whole
Except, yeah,
Yes, sir.
Yeah.
so there's our parabola. Now, what did we cancel from the bottom? What do we need to worry about?
-5.
Negative 5, well, x minus 5,
X plus
5.
Then the one we don't have to cancel.
Negative 1.
There's still, is it included already?
Well, is it included?
No.
Sure it is. Where's x?
You can't. Oh.
Right? But we can't have x equal to negative 1. So there's a hole there too. So that's what that parabola is going to look like. It's going to have 2 holes. Oh, funny. There was a question about that earlier. Okay, from in front of you. So yeah, this thing looks like a parabola,
It is.
except there's a hole at -1 and there's a hole at 5.
Nice.
Right? You guys are packing up like.
Ryan has stuff confused, and I tried.
I know.
I'm just very.
But you're going to want to see this last thing. You're not going to do anything. There are times where you're going to have to do polynomial division. I'm not saying it's pleasant. But those 2 things that I have up there don't cancel. Neither do they cancel. They don't do either. Now, if we did polynomial division, we would get x plus 4 goes in 5 times. That would leave this as a 5x plus 20 if we have one too many. Okay, it's going to be minus 1, yeah, 1 over x plus 4. Right, that's the remainder. And can we graph this?
Yes.
Yes.
Yeah.
And
It looks like -1 over x plus 4 plus 5.
And then it would be
Where's the center?
4, 5.
No.
Negative 4, 5.
Negative 4, comma 5 is where the new, like, origin is. One other thing, what about where you're going to draw this?
It's going to be flipped.
Yeah, because this negative is going to be in our new quadrants 2 and 4. So if I move this over negative 4 plus 5, this is totally not to scale. But it's going to be flipped. It's going to be in this quadrant and that quadrant. Right, because of the negative there.
So it's always in those.
Yeah. Okay. There's one problem. It's the last problem. Just like that on the problem set. Okay. So, and I even tell you, use polynomial division. So it should be obvious which one you use polynomial division on.
Did you turn it around?
Some people are privileges, I think is what they're saying.
So yes, you're right.
Yeah. That's good. People are silent in the hallway. Have a good weekend. Have a good weekend. Have a good weekend.
Brad ruined it. I tried to fix it.
I don't think anything's ruined over there.
He messed it up.